All right, now we're going to take a look at the two problems on the handout here. We're looking at problems 2 and 3. So right now we have a right regular hexagonal pyramid. The base edges have length 6 and the lateral edges have length 10. We want to find the volume of the pyramid. Now, as we remember, the volume of the pyramid is 1/3 the area of the base times the height. The area of the base is going to be something we'll take care of in a bit, but we want to determine the height of the pyramid here first. Note the only thing that we have is a 6 and 10. Now, the nice part about this is that remember that we always meant that for a right hexagon, for a right pyramid, the height is always going to be, so the apex, the height in this case is always going to be perpendicular to the base, and the apex is always going to be directly over the center of the base here. So we can go ahead and set that up here. So we were to change our view so that it looks like this now. The base looks like so. We can see that our height is going to be directly over the center of the base here. Now, you remember the center of a regular hexagon here is just simply the location where the 6 equilateral triangles meet. So we can actually set it that way. And therefore, we can do something like this here. We can connect something like that. And we'll see that this thing here corresponds with this over here. Now, since it's 6 equilateral triangles and all these have side length 6, it's pretty clear that there's a 6 here. And now we can see that this is 6 over here as well. So now we can extract this triangle like so. And now we have a triangle that looks like this here. This is 6 and this is 10. This is a right angle. So it's pretty clear that the height of this pyramid here is going to be 8 from the Pythagorean theorem. Now we just need to figure out what's going on here. So going back to this, we see that this is 6 equilateral triangles. So the area of the base here is going to be 6 times equilateral triangle. Now the equilateral triangle, if you remember, is s squared radical 3 divided by 4, where s is the side length. So you have 6 times 6 squared radical 3 over 4 here. Okay, so let's see, 6 squared is 36. 36 divided by 4 is 9. So you have 6 times 9 radical 3 here, which yields us 54 radical 3. Okay, so that's the area. So now we can actually put it all together. So we can say that the volume of the pyramid is going to be 1/3 the area of the base, which is 54 radical 3, times the height, which is 8. Now a third of 54, 3 goes into 54. That's quite nice here. I believe it goes in 18 times, so we can do that. So we have this here. So we have 18 times 8 here. Let's see, 18, 8 is 4, 6. I believe that is 144. So the volume of this pyramid here is going to be 144 radical 3. Okay. Now, this problem here comes to us from a contest. So we have a diagram here. We have a triangular pyramid with base BCD, and the edges are all mutually perpendicular to one another like this, which is the most important part here. All these are right angles here. So we have AB is 5, BC is 6, yes, and AC is 7 here. We want to determine the volume of the pyramid. So again, we'll do this here. So we see that the volume of the pyramid, again, the volume is going to be, area is 1/3 the area of the base times the height. Now, if we look at the things here, the nice part about this is the fact that these are all right angles here means that in this situation, let me label each of these pieces here. I'm going to call these pieces here, let me call this A, B, and C. Right? So A is going to be the length of AD, B is going to be the length of BD here, and C is going to be the length of CD. Now, note that the base is pretty straightforward, right? The base is just 1/3 the area of the base. The area of this base here, this is a right triangle, so it's 1/2 B times C. Okay? And the height is A. So therefore, this is just ABC divided by 6, which is fantastic. Sadly, we have no idea what A, B, and C are. So we're going to have to get a little creative here, okay? Note that they gave us the 5, 6, and 7 for a reason here. Some of you may have noted that because these are all mutually perpendicular, there are a bunch of right angles here, and therefore we can create a bunch of right triangles. So in fact, we actually have right triangles that we can deal with here. So if we look at triangle, for instance, triangle ABD here, we know that this here, this is the legs, AD and BD are the legs here, and AB is a hypotenuse. So therefore, we can write one truism. A squared plus B squared is 25. Right, from this triangle here. Similarly, we can do the same thing over here. B and C is 6. So here we have a right triangle BDC here. We can do that. So we get B squared plus C squared equals 36. And we can do the same thing on this side here, AC that. And we can see A squared plus C squared is 49. Now, for those of you in my math team class, you'll recognize this from the beginning of the year. This is a symmetric system. For those of you who don't, you'll note that this is a symmetric system because you'll see that every single one of these equations has exactly 2 to 3 variables, and each variable is missing exactly once. This first equation is missing C, this second equation is missing A, this was missing B here. So the best way to tackle something like this here is we're just going to add the equations together. So we're going to sum straight down here. You'll note on the left-hand side, when we do that, we get 2a squared plus 2b squared plus 2c squared. Each of the pieces are missing exactly once, so instead of showing up 3 times, they all show up twice each. The right-hand side, we can add this up. Let's see, 5 plus 6 is 11, 11 plus 9 is 20, we carry a 2 here, 2 plus 2 is 4, 4 plus 4 is 8, plus 3 is 11, so we get 110 here. So we can divide both sides here by 2 and get a squared plus b squared plus c squared is 55. Now, the nice part about this is that now we can go back to every single one of these equations here and subtract, right? So in this case here, we can take this and go back to this first one here, right? We have a squared plus b squared is 25, and c squared is 55. A squared plus b squared plus c squared is 55. So that implies that c squared is 30. So it implies that c is radical 30. Similarly, we can do this here. We can now do subtraction. We can subtract each thing here. So in this case here, b squared plus c squared is 36. We have 55. 55 minus 36 here. We get b squared, I believe, is 19. Let's just make sure. Yes, it is. So we get that b is the square root of 19 here. And finally, a squared, we do the same thing. 55 minus 49, I believe that's a 6 here. So a squared is 6. That implies that a is radical 6. So now we can actually put everything together because now we know the lengths of A, B, and C. So the volume here is going to be the square root of 30 times 19 times 6 all over 6 here. And now we can put this together. The nice part about this is that we see radical. So the nice part about this here is that 30 is 5 times 6 here. So I can actually gather a 6 and a 6 here. So I can yank out a 6 squared. Right? Because there's a 6 from 30 and a 6 from 6 here. And what's remainder is what's left is 5 and 19 here. So we have a 5 and a 19 here. We divide this by 6. So we get all this here. So therefore, this here is going to be 6. So the radical 6 squared is just 6. So this is 6 radical 95 divided by 6. We divide these out, and we find that the volume is merely the square root of 95.